Hello everyone, welcome to our, this is a kind of overloaded event. It's both a lecture in software architecture and at the same time this is a seminar of our research group called Advanced Software Development. So welcome you all, and I would like to introduce you Marko Ranković, who is a deputy director of RPC, Raiffeisen Card Processing Center, Regional Card Processing Center, but it's a part of Raiffeisen Bank. So I'm very pleased to have him here because he has great experience in very complicated, complex architecture settings related to containerization. So I don't want to interfere with the content of the lecture. So this is Marko's lecture. So I leave this content to him. The lecture will be organized as like some 1 hour, about 1 hour of lecture, but then we will have a great kind of bigger time for discussion. Anyway, if you would have any questions, I think you can ask.
Either during the presentation or after, whatever you prefer more. So
you can ask immediate questions. Just ask whatever you would like to ask. Don't hesitate to do so. And the lecture will be recorded, and it will be available as all the lectures in this course. So the floor is yours.
Thanks a lot, Valentino. I will walk around. So good to see all of you. As Professor Valentino said, overcrowded. Well, depending on the perspective, obviously. Good to see all of you. My name is Marko Ranković. As Valentino said, I am working as Deputy CEO, COO of Regional Card Processing Center, which is part of Raiffeisen Group. And it is my pleasure to be in front of you today and tell you a bit more about complex containerization. In life, in general, I tend to simplify things, but sometimes oversimplify. So this is how I approach this lecture and presentation. I simplified it. If you have any questions when it comes to the rules, please ask, either during the lecture. The ones who are in the back seats, please yell so we can hear you. The ones in front, raise hands or something. And or at the end of the presentation. So it will be around 1 hour, more or less. We'll see. And good. So topic for today: container-oriented architecture with its implications. I will also share with you some practical examples, but let's start. So, agenda. We will see what is the container-oriented architecture. We will guide you through some, I will guide you, not we, it's only me. I will guide you through some principles. What are the main building blocks by design, what you need to pay attention at when you would use containerization, and some practical examples from real life. About RPC. So, as said, RPC stands for Regional Card Processing Center. It is in banking industry. In banking industry, then very specific niche. It's card payment processing. So when you are going to buy something in store or shop or withdraw money from the ATM, that transaction potentially is coming to RPC. We are processing the transaction, validating, and not going into now expert part of the card processing, but we are the ones who are also enabling and empowering payments to our customers. Being part of Raiffeisen, we are servicing only Raiffeisen customers. So Raiffeisen customers in 11 countries in Central Eastern Europe and Southeastern Europe region. currently outside of our scope are Bosnia and Russia, Belarus, for obvious reasons. Yeah? But we are looking at Bosnia soon. So to give you also at a glance impression of the size, we are processing 1.5 billion transactions per year, which is a significant number. And even more, we are processing around 2 billion of API calls per year. And this is important when it comes to the containerization, how this infrastructure can handle such load. Per month, it's easy to calculate. It is between 150 million and 200 million API calls monthly. When it comes to me, so this is the position, just to also resemble with the picture. Myself, I spent most of my adult life in banking, in financial industry, namely in processing. I'm native Serbian. I work, as you see, in RPC. Previously, I held positions also in payment processors. I was working in the bank. I was giving lectures and still part-time in one university in Serbia. I was also at a couple of institutes. I published 4 books, 50+ lectures. I was football referee, Futbalovi Roskovca. 15 years. I was refereeing 4 years in First Serbian League. If you want to discuss also rules, yes. If you want to discuss Serbia-Cameroon from yesterday, no, please. My heart still bleeds, so let's keep that topic. And I'm married and father of 4. Before we got kids, I was tall, 2 meters, blonde hair, blonde eyes, muscular, fresh, and look at me now. That is the consequence. So, good. So, containerization. Do you know what containerization is? Apart from professors. Have you heard? Not speaking about containers for garbage, but software containerization. So, there are many definitions of containerization. Container-oriented architecture is empowering us to develop, deploy, deliver software applications in an isolated, more or less independent way. And it is simple as that. Furthermore, you will also see what are the implications of this approach. This is giving us opportunity to deal with these applications in a different manner than usual software development and software deployment. It has its pros and it has its cons. We will go through. Containerization or container-based virtualization. It's virtualization on the operating system level for deploying and running distributed applications, but without using resources of operating system per application. And you will see how the architecture is based. Question, do you know which programming concept enabled containerization? Okay, I also did not like guys who were asking questions all the time. So, have you heard about object-oriented programming? You did? So this is prerequisite for the containerization. And actually, object-oriented programming was prerequisite to come here. In the beginning, with object-oriented programming, I started also as developer. I was introverted, did not like to speak. You would not say now that, but I was programmer on mainframe, IBM control language and RPG and RPG ILE. Also left some consequences of my mental state. Graphical interface was 60s, like monochromatic green screen, so green and black, and I still like it. So it was like DOS-based. RPG logic was COBOL-based. I also had chance and luck to program in COBOL. Invert logic, but still, it is good language. Back then, I'm not ages old, so some 20, 25 years ago, the topic was how we can optimize and how we can call different procedures. For example, convert date, standard one, day, month, year, to Julian date. Do I need to type it all the time? And then there was an object, simple procedure, which is being called convert date to Julian date. So this Julian date converter, you were able to use it all the time. It was object, and it was one of the prerequisites for container. So it was container-like concept. Good. So this is something which is known. You are having hardware. On that hardware, there is some operating system which is running. Operating system supplying application with necessary resources to run and to deliver, and you have end user. Container-oriented architecture is this. So you are having containers, you are having applications with its binaries, container engine, which is across or only one container engine is per operating system, and then operating system and hardware. You see that in this case, each and every application is consuming the operating system. In case of container, you are having container engine, which is handling consumption of operating system optimally, sharing its resources. So for operating system, container engine is actually only one application, and it's not seeing other applications. On other graphical representations, which I will show you afterwards, it's different than virtualization. You heard about virtualization concepts, yeah? Good. Virtualization is something which is, you are bringing up virtual machine, but each and every virtual machine is having its own operating system called guest operating system. Guest operating system is speaking with hypervisor. Hypervisor is something which is between main operating system and guest operating system. So, containers, some of the definitions or descriptions, they're fully portable, independent software units. Meaning, you can run container, you can run an application in the container, in one environment, and then simply bring it up to another environment. Even environments which are different per nature, depending on the application, you are able to utilize application even cross-environment. Cross-environment meaning not only on the specific piece of hardware or environment as a total production, or let's start from the lower, development environment, test environment, UAT environment, pre-production environment, and then production. Not even in this ecosystem, but you can take it out. Take it out and deploy to completely different environment, and even potentially with completely different operating system, and still able to utilize. They are compatible with particular environment, but that can be easily adopted because you saw the binaries. You saw the binaries here, so the binaries are connectors, yeah? And these connectors can simply be adjusted. They are similar to virtual machines in the virtualized environment, but as said, I will also show the difference that containers are something which is more efficient to deploy. And also, there are no licenses attached to deploy. Virtualization, again, you are having VMware is placed on some VM farm, it's all costly. Here, you are having really portable matrix-like units, Agent Smith, which can be easily replicated. They are lightweighted comparing to virtual machines. Do you know why? I already told you, but I said, okay, no questions. They are lightweighted because they are not utilizing and not taking OS resources. You have container engine in between. Yeah? And can have either specific or general functionality. What this means? We mentioned normal date to Julian date. This is something which is general. Still, you can have, for example, in financial industry or card payment industry, you can have function get card data. Get card data is very specific function. It's very specific to the system. But example of get card data container or get card data API in the container is cross-bank. So we are implementing get card data, and get card data is a container or API, which is calling the system and getting card number, expiration date of the card, and what you need else to pay when you're buying over the internet. There is card number, there is expiration, and what else? Do you buy over the internet? Do you hear me? Do you see me? Good. Good. I was worried for a second. That was the most common two questions over the last 2 years. Do you see me and do you hear me? Do anyone bought anything over the internet over past years? You did? Good. Do you remember which data you used when you're buying over the internet? No? So it's card number, its expiration date, and its CVV2 number, which is on the back of your card. It's 3-digit number. So get card data. Whenever you want to buy something, for example, you're using mobile application and you have some applications, for example, Tatra Bank application, generate me one-time card, only for the internet. Generate card, and you are getting exactly these three information. So coming back to the containerization concept, one general container specific for example, RPC environment is get card data container. I can use it for Tatra Banka because Tatra Banka container get card data will hit to the database and then ask from the fields this data and transport it to the mobile application. But then I can simply copy-paste, literally copy-paste it, only different table identifiers for example, Raiffeisen, I don't know, Serbia or Kosovo or Romania. Super simple, simple as that. Do you have any questions? Okay, good. So, just other graphical examples. This is something which is regular one, no containers. Different applications which are hitting the same operating system, and these applications are, I can also say, proprietary for the particular environment. Comparing to hardware, operating system, then container engine, and then containers. Another one, applications in containers, then Docker. Have you heard about Docker? Anyone would like to tell me what is Docker? No? It's container engine. It is one of the most famous container engines. Yeah? And then, what is then next level of after Docker? What you can potentially have? Kubernetes, exactly. And Kubernetes is service which is managing actually Docker-like engines. And this is the same. Good. So let's go and discuss about some main attributes of the container-based applications. Some of them are here. Observability, and these are the most common and most important. Then image immutability, disposability, security, and CI/CD pipeline. So, observability. What does it mean? It means that you need to have control over your container or over your image. Container health check. It means that application which you built in container needs to be regularly checked whether it is responding, whether it is working, and you need to find points how to manage this. One example. Let's take get card data or any other application, I don't know, user-oriented application. Health check would be that you are having dummy message which is asking application to respond. Depending on the criticality of the application, it can be every second, it can be every minute, it can be every hour, but you are asking for response. So you are generating dummy request and you are expecting a response to the dummy request. This will tell you, it's actually health check or handshake, call it whatever you like, something which is telling you that application is alive. In financial world, we are having really echo messages, which are called echo or handshake messages. Type of the message is 0-100. You will see it at some point, maybe, who knows, where I'm asking system literally, are you alive? And I'm responding as a system, yes, I am. Monitoring. The next point. Why the monitoring is important? Where if you are having health checks, then you need to, and you want to put results of this health check somewhere. Potential tool to be used, I don't know, SMTP, network devices, Zabbix, Grafana as a representation layer. So you are asking system, are you alive? Or you are asking container application, are you alive? And then you are logging this result somewhere. Based on the logging, there is an action. Action can be call support, wake up someone, something is not working. Unfortunately to my wife, I'm working last 20 years in 24/7 environment. 24/7 environment means that you are paying and you are buying all the time. So Black Friday was last Friday, and you are using night time to buy things during the Black Friday. Yeah? For some reason, previous years discounts, I don't know, starting at 10 p.m. or 11 or at midnight. I said for unknown reason to me, obviously not to give me a chance to sleep. But this is for me for decades, not only for me, but for all colleagues who are working in the payment industry. You need to ensure that system is working properly. In RPC, I can share with you that we are having, of course, health check systems, not only for the containers, but in general. And there are 4.5 thousand triggers. 4.5 thousand triggers which are logged in the monitoring and generating some alerts if needed. Even Zabbix, we are using Zabbix mostly. Even Zabbix is a high availability and redundant system. So there are two instances which are working in a high availability setup. Logging engine, it's important for different and many purposes. One of the most obvious is security. So if I'm doing something with the application, then I would like to log any action with that application. If I'm going to erase something, if I'm going to change any parameter in the application, containers needs to enable that all actions are logged. And of course, you need to have some logging interpretation. If I'm changing something of the critical parameter, the question is, am I entitled to do it? If something is happening, now we are coming to the responsibility and finger pointing, there has to be trace that something was done. And most of today's applications which are containerized are API-based applications. Speaking about technology, usually REST-based APIs, but also older or newer technologies are used. Questions? Good. Then image immutability. Do you know what immutability means? It's interesting word. Interesting, but I would say normal for the virtualization concepts. Immute means unchangeable, immutable. It means that image which we are creating from the source needs to keep its integrity. If we put here image integrity, it would be more or less the same. But integrity of the image itself has to be unchanged. So when I create the image, up until I restore the image, it has to be kept. What it means, we need to have version deployments when there is a change of the image, when there is a new version of the image. You also see it, I don't know, Viber or WhatsApp version 126.9. This is how they keep track of the application version. It is versioning of the containers, in general in the software development, is super important as a concept and has to be done very diligently in order to keep control over your software delivery. Then images. With container-based application, this is really as simple as copy image, build new, deploy, and dispose. It really should be developed in a way that admin or developer doing it like this. Depending, of course, on the application weight, it should be done in seconds, depending on the infrastructure and everything, but it is a matter of seconds that I'm able to deploy my container to the different environment, to build it, to rebuild it. Automated pipeline. What it means, it is connected to versioning, which can be based on some criteria, automated, that version of the image is updated by itself. This is, of course, for the advanced software development. Why? Because simply sometimes you need to have control about new version, but sometimes some parameters of the application can be updated automatically. In container world, update would mean deploy new image, dispose old, deploy new. And backward compatibility. What backward compatibility means? It means that if you are changing version of the container to the upper version of the container still has to communicate with potentially old version of the OS, which is not being deployed. Or if you are having interconnected containers and you're updating or upgrading one, still you need to ensure that this container will communicate and cooperate with the container of the previous version. Examples, mobile phone. So if you are developing new version of the maybe mobile OS, but let's take a simple mobile application, game or whatever, user-oriented application, you are not changing your phone. I don't know, Waze. Waze, you know Waze application, all of you, I suppose, yeah? So I'm having new version of Waze. They're upgrading the Waze to the new version, but developers need to ensure that new version of Waze is going to work with my mobile phone. Or communicate, I don't know, Android OS version 10, this version needs the OS version 10 as a minimum. But in most of the cases, you are not cutting your legs, and developing application which cannot be used on majority of the devices. Disposability of containers is super important as we are building lightweight applications. Scaling is one of the most important things which we need to take care about containers. Scaling means if I need more power, then I will scale. Scale by copy-paste. This is, again, super simple. Do you know any example of scaling? Pay-per-use models. Scaling by, so if I need more resources, I can just switch on more boxes somewhere in behind. Any concept that comes to your mind? CPU? Yes, but in which environment, for example? You don't have endless, except in one, potentially. It's cloud environment. So cloud environment is perfect example of scaling. When you need more power, you are extending resources. Resource extension in cloud is usually automated. Of course, depends on business model, but usually automated. I'm having some utilization. If I need more resources, they are added automatically. Containerization can be set up in the same way. I'm having, for example, one container application, which can handle 10 parallel threads, or 100 or 1,000 parallel threads of requests, all open connections. Once when I'm reaching threshold, for example, if it is 1,000, I'm reaching 900 threshold, then automatically new container is being deployed and is able to take over the load. Fixing deployment and shutdown. As part of the life cycle, you will definitely need to apply some fixes to your containers. This should be, again, super easy because at the beginning we said that containers are isolated, independent units which can be deployed easily. This enables us to deploy containers and to fix containers in a way which will not harm the system. Potentially, And this is potentially, this is something which is used. You're having one instance which needs to be fixed. Of course, assuming that instance is still running. You're able to replicate second instance to make it running, to switch this down, fix it, and switch it on, while the load is taken by another container. Deploy it easily and also dispose it easily. You're going to the next, I don't know, making container more complex, having more functionalities in it. You're putting new version in and disposing the old one. And it should be super seamless. Of course, all of this heavy depends how you are thinking as a developer, as a programmer. What is your logic? So the prerequisite is that you have healthy logic to develop the application. And security. Better than this guy. So manage access to containers. In financial industry especially, but also in other industries, you need to have access regulated to your containers. Regulated means there has to be access list, there has to be roles and privileges to the person who are accessing, because roles can also differ. You can have only view right, you can have right to change something, and this is very important, to have also this segregation of duties in the software developing. Then trustworthy images. This is connected to the previous one of image immutability. That images, you need to be sure that images which you are creating are trustworthy, meaning they are not hindered or changed during the deployment process. Security testing tools, like Rasp, for example, which is enabling us to test the load, to test the code, and to see how our code and how our logic is behaving. Vulnerability scans. I put vulnerability scans here, so depending on what you do, actually. In financial industry, in car processing, vul scans are regulatory mandate, and you have to do it. Having said this, you also need to think how potential crooked people are thinking, whether they are able to. So they are quite innovative, I have to say. Yeah. Having said this, you need also to think from the other shoes. What I need to do in order to protect myself. And again, backward compatibility for the security features. I can share one experience with you where containerization, and the containerization is also base for the infrastructure as a code. You heard it, I believe. Yeah? Infrastructure as a code is ability to deploy applications, but also to deploy logic behind as an application. What we had last year, and in the industry, it started with DDoS attacks. You know what DDoS is? So DDoS is a distributed denial of service, as we are also in the industry where internet payments, as we discussed a bit, are there. Having said this, so there was an issue with distributed denial of service where 100, 200, 500 gigabits per second were attacking the infrastructure. With infrastructure as a code, you are able to replicate and to distribute load, actually to build network component as a container, as a software, which is able to distribute the code, to distribute the load over the infra. And in the end, CI/CD pipeline, easiness to execute, where you are putting your software components in a pipeline, continuous implementation and continuous deployment. Their deployments are automated, so there is no manual typing on production environment. So you are preparing the package, you are deploying in test environment, you are testing it, and then by click, you are just publishing it to production. And for this, of course, there are certain tools which are used, GitHub, GitLab, where you are using them for publishing the tools, publishing the applications. Questions? You are persistent. I am, but you are better than me, obviously. Good. So how containerization fits into the existing landscape? Business environment. Business environment in banking, but I would say not only in banking, increased in speed in multiple times over last 10, 20 years. So the speed is, the pace is really fast changing. We are speaking about environments where you need to adapt sometimes even daily to the changes. And containerization is definitely something which is helping us to do so, especially in scaling, especially in simplicity of the applications. Cost efficiency. As said, you don't need additional hardware. You don't need additional licenses. Of course, you need a base. This is definitely, yeah, so you need a base. But you will be able most efficiently or more efficiently to utilize your resources with container-oriented architecture than if you are having these monolithic applications which are consuming the infrastructure resources. Flexibility. In business environment, this is something which is super important. Customer needs, if you look banking customers, evolution from either 2000 or 1995 till now, it's uncomparable. Uncomparable. Merchants, for example, if you take merchants 20 years ago, merchants were coming to the banks and negotiating their terms. And banks were in charge. Today, it's a completely different story. Now, bank is going to the merchant and offering the terms. And merchant is sitting and choosing which bank I want to choose. With end users, unimaginable. Comparing to the branch visits in 1990s and before, and then onwards, utilizing internet banking, then utilizing mobile banking. I'm living in Slovakia for 3 years now. And I've been in Tatra Banka branch 2 times only. And able to, of course, first time when I was opening my account, second time, other occasion during the summer. But no need. No need. This is important from different perspective. Also having its cons. Me as a user, I'm also able to see all banking conditions in the whole Slovak market just typing 2 sentences. Still, but me personally, what I personally miss is a socialization component. I'm not speaking with my bank at all. So French concept of banking is I need to have a branch in each and every village, if not more, where I can speak with you. Yes?
How come you have your account in Tatra Banka?
As non-resident.
Because why not Raiffeisen?
Tatra Banka is part of Raiffeisen Group.
Oh.
Yes, yeah, of course. Come on. I'm not risking my life here. There are two Raiffeisen entities in Slovakia. One is Raiffeisen Slovakia, and second one is Tatra Banka. While management of Raiffeisen Slovakia is actually management of Tatra Banka.
Yeah, okay.
Yes.
I was not aware of this.
Yes.
But maybe a more serious question. These are implications from the user side. What are the implications from? I mean, you mentioned this, but how it is different from the developer's side? Building such applications, building their architecture. One side is this architecture is underlying architecture, so the whole thing that you operate upon. But the other thing is how does this affect the way you develop your applications?
Thanks for the question. So first of all, you need to have a base, yeah? And when it comes to the developing logic, you know that you are developing one thing for all. And this is the main concept. So it's one to many. This is the relation. If you are developing get card data. Let's take this one. So you are having base application, which is mobile application with all mobile application flavors. And then you are building blocks. Blocks are attachable and detachable. This is the logic this has to be logic of the developer. That his application is, we mentioned the graphic card or, I don't know, 90s was a plug and play concept. In containerization, in container-oriented architecture, plug and play is the leading principle. So I'm having mobile application, and I have function get card, which can be there, can be switched off like this, and can be switched on like that for the first time. When it comes to other customers, again, it's super easy because I know that I'm going to 100% or close to 100% reuse this software component. And this is the main advantage for the developers. Container-based thinking, to start with thinking, but then when it comes to the applications, reduced, depending how many customers you have, but it's 1 divided by number of customers. This is how much time it saved. I hope I answered the question. Yeah. Ask me the...
No, let's go on
Yeah.
to the lecture. Maybe afterwards other colleagues will have questions and maybe we'll
Yes.
some other things because I think this very complex thing of how people do develop software, what's their position and how organizing people affects software, and I'm very interested in this.
I will address it on the...
I guess you might come to this in your lecture, so I don't want to keep...
It is part of blah blah slide. I will address it. So, technological environment, fast deployments, as we mentioned, plug and play. So you are expecting that container-based, as said, answering to Valentin, it is attach or detach. And when you attach it, it should work seamlessly. Impact on the overall system stability, meaning that you have isolated software components where the main principle is that if one software component is not working, only that software component is not working, not the whole system. This enabled, for example, when speak about mobile banking, that when something is not working in mobile banking, you are having these widgets where potentially only widget is not working. But you are able to use your mobile application still. Service availability, of course, it is connected to the previous one. SLAs or service levels in service level agreements and service level values towards the customers are 99.99, in some cases 99.999% of the time. So virtually it is available all the time, and this is something which you need to support. Key pillars: container-based architecture, engines, and the orchestrators. Engines. So engines are based on an operating system where kernel allows multiple and isolated application instances. So as mentioned, you need to have a base on kernel level which will support utilization of the OS with attached container engine. They are handling user inputs. So whatever you are manually or parameterizing the application, then they need to handle. Super important when developing containers is also exception handling code. So you are developing positive paths, but you are also developing all negative paths. What needs to be avoided, of course, not only in container development, but in general in development, that you are depending on input. And this is very important. What you need to ensure? You need to ensure that input is not breaking your application. Similar logic as in communication. So if you are asking me something, I should not start crying. Hope so. So if you are asking, I need to handle your question. Similar and same with the application. If there is some input which is coming, either through manual input or through API input from other system, I need to be able to handle it. The engines are managing images, so image itself, building the image, metadata preparation, mounting the image, and container runtime execution, meaning that some applications, container-based applications, are having schedulers behind. So, for example, container-based batch engine is executing each and every night at 1. There is a schedule, so there is no one who is manually starting the engine, but it is executed via scheduler. When we are having environment with 1,000, for example, 1,000 applications or containers, then runtime execution is something which is extremely important here. The most popular applications or the most popular engines is mentioned Docker, AWS Fargate, Google Kubernetes engine, and Microsoft Azure with, of course, not whole Azure, but part of it is also container engine. Orchestrators. But orchestrators are helping us with is to have a completely automated management of the engines. They are on the next level of engines. They are enabling container deployment. They are enabling us to scale and managing lifecycle. Lifecycle, we mentioned, building the image, deploying, fixing or managing through the life of the container, and in the end disposing. They are increasing system resilience. Why? Because with scaling and automation, container orchestrators are also able, depending of course on the application itself, but Kubernetes, for example, is able to identify whether container is performing or no, and to automatically deploy new image of that particular container. This is first try to fix topic. The most popular ones are Kubernetes and OpenShift. Kubernetes, I would say, the most used also one. Benefits. Benefits are potentially huge. So, seamless and fast setup. Containers, as said, you need to have a logic behind your logic, firstly, as someone who is developer. But it should be seamless. Deployment of the containers, container-oriented applications should be really seamless. Resource-efficient solution, as said, utilization of the OS with container-oriented architecture is optimized. Efficient utilization. Resources are not as with virtual machines, so there is no guest OS, there is no increased OS utilization. Application level isolation, safeguarding the system stability, safeguarding the system availability. They are easy to deploy and reducing overall time to market. So when I'm building container for first customer, then it is ready to be deployed for all others. You need definitely some time, first time to develop and to deploy. For the next customer, it should be seamless. Challenges. Since containerization is rather relatively new, knowledge of IT resources is scarce on the market, not only on Slovak market, but in general. You can hardly find someone who understands the concept and who is able to manage container-oriented architecture now. Of course, there are people. I mean, there are container-based systems as one is in RPC, but this knowledge is also built over the years. Can be bought. It's very expensive, and definitely it is. I would not say completely future, but definitely it is part of the future. Cloud connections. Today, everyone wants to go to cloud. This is a trend which we see overall. In some cases, definitely makes sense. For me personally, it makes sense to go to cloud where it makes sense. So using common sense and pure logic to decide yes or no. I can tell you that Raiffeisen Bank in Ukraine, for example, they started their cloud journey something 2 years ago. And because they started cloud journey 2 years ago, they were able to move the whole core banking system to cloud within 5 days after the war there started. And currently they are managing the whole core banking from cloud. And this is what safeguarded the bank. It helped the bank to survive. Complexity. As we said, you can have 1,000 containers. So if you are building, I don't know, in the very beginning it will be some, but then you can really scale up and you can come to a situation that you're having thousands of applications which needs to be managed. And you remember about observability, about monitoring, health checks. You need also to build all the infrastructure around to be able to handle. And security challenges. When it comes to security challenges, here, since all applications are connected to container engine or to Docker, still there are challenges how to isolate from Docker all security features, user rights, roles and responsibilities with each and every container application. And this is something which is posing the main challenge currently. When you should use it, start with simple, and this is very important. You will not be able, and then also there is some learning curve and also scalability curve. In RPC, we started with really several API-based containers, and then scaled it up. Currently, we are having more than 500 containers which are processing and handling, as said, close to 200 million API requests per month. But definitely start with something simple to test. Maybe the concept of containerization in the end will not work for your company, depending on the nature. Nature of the endeavor, just mentioned. Investments, depending how much money you have and depending what you need. Investment part is very important. If you are having endless budget, which is never the case, virtualization potentially can be an alternative. Still, this alternative is heavily connected also with containerization as a concept. Only difference is that you are bringing up virtual machines, not applications. Speed to deploy, we mentioned it. POC, proof of concepts, in this respect are quite fast and quite efficient, because you are able to develop isolated application for certain feature and to test the concept rather quickly. In some cases, matter of days even. Of course, depending on the complexity, depending on the features. But it's also important to bear in mind is complexity which you are dealing with. I mentioned you only one, this get card, which is a good example. It is super simple call. Super simple call. And it's easy to manage. It's not resource consuming call. It is asking the database, the particular table, to deliver 3 fields only. And this is one good example of the container. No, and this is something where developers sometimes are getting caught in a trap. Okay, I will bring this, 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 and then the application is growing. When application is growing, complexity is growing, resource consumption is growing, speed of the application is decreasing, and then you are coming to the, you have container, which is like this dock container on a shipyard with tens of features and functionalities, and it should not be like this. It should be 1 or 2, 3 at most. Keep it simple. And blah, blah slide. RPC case. So, and now I will maybe address your question. Where we are using it. So, apart from authorization processing, as said, 1 billion authorizations which are coming from POS terminals, from ATMs, from internet payments. We are having infrastructure which is in parallel with this infrastructure, which is called micro-hub infrastructure. Micro-hub infrastructure is completely API-based infrastructure. And we are using it for all non-authorization requests. Non-authorization requests are API-based, all of them. So when I'm taking my phone and switching on my mobile application, when you're switching on your mobile app, with which you can pay, you see your card, yeah, usually. Well, this presentation of the card is one call. Your card actually is not in the phone, but when you are bringing application up, there is a call to identify first. So sending fingerprint of the device with the system to identify. This is one container, one validation. Then validating my second factor is what I know. What I know is my PIN, for example. This is second container. And second container has application. Third one is show the card. Fourth one, show me the balance. This is fourth container or fifth. And this is the logic. Each click which you made, you are calling application behind, which is micro application, which is super small, container-based application. And thus, this enables to the mobile banking application to be super fast. When I was working in the bank, I was on the dark side of the story, like to joke. Some 10 years ago or so, that bank was the first digital bank in Serbia. So it was Telenor Banka. Both KBC was sold to Telenor, or Telenor bought KBC, and it was the first digital bank in Serbia, maybe even in the region, solely based on the mobile application. Concept was mobile first. Why this is important? It is important to say that the first application which was developed to have all banking services within was 120 megabytes. 120. It was super big. It was super slow. It was well performing. Yeah? It was a bit slower than expected because of all features. And it was rather monolithic mobile application. It was one application. How today mobile applications are working. You are having a framework. You are having a frame, literally, of the application. All rest are APIs. All rest are calls which are having container behind. At least currently in RPC. I cannot speak for others. This enabled us to deploy the frame only, which is super light. This empowered us to have all functions behind the mobile application, which are completely isolated. If get balance function is not working, you still can pay. If get card data is not working, you still can pay with your phone, but you cannot make internet payment. You don't have that. But important is that there is no interdependency almost between these applications. So instead of one mobile banking app, you're having mobile app framework with 100 micro applications within, or 100 micro calls within, which are all API based. And this will be complete change of mindset how developers are thinking. Also adjusting from get card, get balance, get show PIN functionality. They're all deriving from the same logic of the application. It's copy-paste, changing the fields in container-based application and then calling them. Going forward to the infrastructure itself, distributing calls between the containers, it is also super easy. Why? Because if we are having, let's take one big bank, Tatra Banka, for example. If there is get balance 1,000 calls per minute, you are seconds away to deploy another container which will handle additional load. Without additional investments, without additional virtual machines, so just copy-paste. And it is done automatically. There are triggers. We are observing the infrastructure of containers. We are checking the thresholds which are set for the utilization. Based on these thresholds, you are able to scale. And it is done without our involvement even. Of course, then you are having next level of monitoring, which is infrastructure, physical infrastructure monitoring, which is taking care about physical memory, meaning when I'm reaching certain threshold of the physical memory, then there is an alert. And of course, needs to give you enough time to react, add memory physically and these kind of things. So approximately 200 million API calls every month So every day it is close to 10 million calls. If we are not counting the weekend where the load is a bit less, then every day more than 10 million calls is being processed. Response time of the micro applications is really microseconds, not the micro, milliseconds, not to overdo it, yeah, but it's milliseconds. When you just look at the entities which are participating, so there is mobile application, it is calling container-based application. Container-based application is working with, of course, with the engine. Engine is then forwarding call to different or another parts of the system. It's called to the database. Database is responding, and we are speaking about milliseconds still, and 10 million calls. So definitely, as said, not whole future, but it is part of the future. And it will play a significant role in the future. That's all from me. Thank you. So, questions?
Thank you very much.
Yes, please.
So how is it with the nested containers? Because when you're talking about
Related to? Sorry?
you're saying that you have multiple very small containers. So, and you need to keep track of the version of all of these ones, and you spin them up and down as you wish. But the way I'm looking at it is, would you be, if you have an interface to an application, you would spin up one container, but you would definitely have a chain of events. So it's not one container which is spinned up, so it's going to be a series of containers. So I'm thinking maybe there's going to be some sort of containers, nested containers, so you can modulate the application larger, more here and down.
So, thanks for the question. I hope I get it. In container-oriented architecture, you tend to keep your container depth flat. This is very important, because if you are going with a nested application in one container, you are losing the concept then. So you tend to keep one application with 1-2 functionalities at most, but keeping the depth of the architecture flat. This way, you are really making it binary, 0-1, 0-1, communication, and then Dockers are high performant, and you are handling all potentially nested features between the containers via Docker. But it's a good question. This is another example how developers are easily, can get caught in a trap. And building up, and then you are having actually application, the whole application, but not small container-based application or APIs, which should be the case, which are actually doing something independently. And then, the question is how you would make a change, for example. Then the change is not easy within the nested container.
Essentially, because you would just update that container would, of course, have a
Yes, but if you are having applications in the container, more than if you're changing one application, of course, you need to change the container in the end, but you also need to think about interdependencies within the container, and this has to be avoided.
How do you keep track of all the containers then?
Kubernetes. There is Docker, so Docker is managing the containers, and then Kubernetes is managing different installations of Dockers. So we are currently having, if I'm not wrong, I said 500 containers. 500 containers organized in 5 Dockers. Approximately, this is something which is, let's say, decision to be able to keep track. It is 100 containers per Docker, and Kubernetes on top. Thank you.
problems, or is it for everything, or what, in your opinion, your experience, isn't it limiting some ways?
It is. It is. It pushes you to keep it as simple as possible, and to have this binary logic. And this is one of the main challenges. Keeping it simple means that you need to have more in scale in terms of number of containers. So you're not building something like this, the big block, but you're building a fence with small blocks. This is definitely increasing complexity in managing the blocks. Functional-wise, you are keeping functionality, I don't know, not from A to B as a block, but A, B, C, D, and you can manage each and every letter independently. Still, you are having 30 letters or 46 in Slovak, which is making complexity to manage the environment. When you are speaking with developers, they are all the time tempted to put more. I'm building get card, why not show pin? Why not this? Because it's really super simple calls. But then, when you're having, for example, it not necessarily needs to be issue with the container itself. Potentially, it can be issue with the database, where database is not responding or field get card is locked. There is application lock, and it's not responding. In that case, application is not working. And then application is not having only get card, it's having show pin, it's having this, it's having that, and then the whole system can be affected. So keeping it simple is a challenge, both mental one, also managing one. Yeah?
Then when you have all these services like this, then it's possible to build different versions of your application for different customers.
Yes.
Like this is more easily.
Yes.
So this is quite related. We talked in this course about software product lines, where you actually software product lines do not imply quite this concept of ultra thin services, but actually they do not impose or push any kind of specific implementation. So this could be understood as one kind of software product line friendly implementation of architecture, and maybe feature oriented.
It is indeed.
These are features out of which you compose your big application.
And even to go maybe step further, so you are having feature vertically, but you horizontally have feature in different versions.
Yes.
Which is, this backward compatibility is very important. And you are having, for example, Raiffeisen on the group level is having application which is managed by RPC. It's called the Raipay application. It is mobile payment application. And we are currently having production versions from 1 to 4. And also within this application, we are having different version of features. And this isolated way of thinking, developing, deploying, and packaging is enabling us to have, for example, very advanced feature, which is, for example, available in version 4, to be easily deployed to version 1. Because it's piece of independent, isolated application, which can work with any backend at the end. And for mobile, this is super important. Even from the customer experience, we had cases in the early stage of development. Of course, there were many mistakes. So this is all normal and all fine, where we were forced to switch off the functionality. But then it was like this, and it's not visible in application anymore. Customer experience is, of course, not good, but not as worse as you are trying. The feature is not working. It simply is not visible. So this concept is, for me, it was change of mindset, I have to say. When I was developing in the past, and usually developers, okay, I'm building the application, it will be the big one. And I'm going to put all what I can into this application. Even you are integrating, I don't know, date conversion. I will put it in. If date conversion is not working for some reason, I'm done. Yes.
Ask how this architecture can help to manage the logic, which needs to manage different states of maybe shared resources and so on.
Shared resources in which respect?
For example, when user has some component and manipulates with it, and this component will change or is changing by his activities.
So if I got it right, first of all, when you're building the application, you're building the limits of the application. Meaning, you cannot build application which will consume 100% resources of CPU, as you mentioned, for example. Yeah. You are tailoring made which data this application is taking when communicating with the resource pool and how it is consuming the resource pool. Simple logical thing. I'm having text input application. Text input application is processing the letters of the application. What I need to do, first of all, I need to set what are the logical limits of my application, which letters it can process. Is it Latin specifications, Latin 2? Is it Slovak letters? Are it Serbian letters, Cyrillic letters? Is there anything which can impede my resource utilization? What can happen? It can happen that you are entering, I don't know, Serbian Cyrillic letter J. And the application doesn't know how to handle this letter J. And then it will consume all resources in trying to do so. This is something you need to prevent. So first level of defense is actually limiting your application in its power and capabilities. This is very important to say. When it comes to the physical level of physical usage of memory, physical usage of the physical resources, yeah, then here you are a bit protected with the Docker. Docker is usually Docker itself as an application, but also this Fargate, it has a logic in itself how to safeguard the system. It will not allow you to consume all resources. This is very important to say. Docker is having engine, which is also enabling him to learn usage of the application over time. So it will assign resources as per his best knowledge, of course, optimal for the application to use it. I hope I answered the question.
I ask if it's possible to maybe decompose the same logic which manages different states and how it affects applying the Dockerization there, because often it's only one app Dockerized as one container.
And when you say different stage of different version of the application or different stage of utilization or
how application or microservice react to different changes of maybe object itself.
Well, you have two sides. So one side is object in the application itself. Application has to be built, as said, simply. So when you're changing the object within the container, it should be easy to do, simply replaceable. If we are speaking about objects which are on the system which is consumed by the Docker, then this is the more complex thing. Meaning, if the object is on the resource pool side, then the resource pool side can affect the whole Docker.
The second one, and maybe the operation connected with the object, when object change, then some operation change over.
If we are speaking about change of the resource pool side, change of the object, change of logic, then we are stepping out of the containerization concept, because then we are stepping into the part where the resources are stored to be used by the containers. And then we are in more traditional traditional way of doing things. Usually, when you are having depending to which part Docker is attached. If you're not speaking about, of course, about OS, but if you are speaking about, let me take one example. Potentially Oracle database. So Oracle database, where you are having resources which are consumed by the Docker and the containers. If you are changing something on the Oracle database side as a source, then complete different life cycle of the implementation, development, testing, deployment needs to be applied. It is monolithic, not container-based. And it can affect, of course, the whole user pool on the right side. Yeah. Thanks.
Redundancy. Because if you're using Docker, you're surely just using one server, right? So
Redundancy is so all components are highly available. You are having at least one redundant component. In data centers, we are having 2+2, meaning one node, second node in one data center, and then physically geo-dislocated in second data center, the same setup. So you have virtually 4 instances. Yes, and they are replicated in real time, all the time. Yeah. And we had challenges. As this is why you have redundant infrastructure. Yeah. Thanks. Please. Yes.
You describe an approach which leads to the architecture you described. And we have sort of different approaches in software development, for instance, use case-driven approach. Can you describe this with some relation between use cases, for instance, and some building blocks from the architecture?
Well, actually, use case is the starting point. So use case is the starting point. And when it comes why I should use something or whether I'm going to use something, it is coming from the use case. The first logical check is use case check. What do you need this use case for? Then the question is how you are going to use your use case, in which environment is going to be applied, and then you are deciding on the approach. Of course, not all use cases are suitable for the container-based architecture, but microservices as a use case, and of course you have experts and business analysts to judge whether this can be implemented as microservice, are perfect for a container-oriented infrastructure. There are several different use cases which are not suitable. I don't know, authorization interface, for example. Authorization interface in financial services, because of the regulatory standard and standard how you are doing it, simply it's not suitable for I don't know, IBM MQs are used or other logical interfaces between the systems. But use case in general is the first and basic guiding principle what you're going to do. Understanding use case is actually driving the rest.
Should we consider one use case as one microservice?
We are taking it like this. Use case, evolution of use case is going from something very big, and then you need to disentangle it into very small pieces.
But actually, I'm not sure if you agreed upon this, but I don't think it is so, because use cases might have many such microservices. Typically, we can see some use cases, we rather call them, sometimes Jim Coupling calls them habits, small pieces of functionality or sub-functions, as Alistair Coburn calls them. But those user goal level use cases are much heavier, and I would expect them to involve many such microservices.
They are. Let's take example. Me as a customer, I want mobile payment application. And this is one use case for me. Then you as a vendor, someone who is going to deploy, you need to understand actually what I want. From this one use case, you're going then into the depthness.
Oh, yes, you decompose.
Exactly. And then when your mobile payment application is a good example to have not mobile payment application as a use case, but have, I will repeat myself, to have a mobile payment application, but 100 use cases beneath it. These 100 use cases are microservices, which are, in the end, you are deploying, let's say,
But those sub-functions.
sub-function. Yeah, exactly.
Yeah. Okay. When we say use case here, we mean mainly that user goal level use case. I think Jano meant those.
Okay, I took it from the from end customer point of view. Yes.
Yeah, yes. So it actually the use cases sum up many effects of many services.
Yes.
Okay.
I had a funny anecdote from when I was working in SaaS. We were going to Banka Intesa in Belgrade and discussing about CRM use case and customer use case. And you know what CRM is?
Customer relationship.
That's a good one, but can be credit risk management too. It was credit risk management in the end. Credit risk management. Yeah. So 10 people from SaaS did not ask CRM use case. We went home and discussed about customer relationship management implementation. Came up with a presentation, asked retail guys to come to the presentation. They came and we presented CRM, and then they said, but we have not asked for. And then we said, but you asked for CRM. No, we have not asked for anything. We simply closed laptops, went to SaaS and asked what happened. We called the guy who asked for CRM, and he said, yes, but I'm from credit risk management department. I'm not from retail at all. And we were super surprised not to see this guy who asked for CRM on the presentation. So it needs to be decomposed and understood.
Yeah, that's why I avoid all
Yes.
three-letter
Exactly.
abbreviations. Can be very confusing.
Yes.
And people just pretend
They understand.
You, even if they never heard that acronym, just because they will seem to be dumb if they admit or ask, what do you mean by this?
Yeah. I'm not afraid to be stupid in the company. So.
I'm afraid that many people who use these acronyms, abbreviations,
Not sure.
really don't know
What is behind? Yes.
but they are comfortable with their users.
Yes.
Nevertheless. Okay, any more questions? I want to kill the discussion, of course.
Just one.
Yes, please.
What was the biggest mistake you have ever made, and what did you learn from it?
Me personally, or related to? Good. Good. So the biggest mistake was the basic one. It was infrastructure. We completely underestimated the infrastructure need. So after 3 months, Endeavor failed. Failed in terms of infrastructure failed. We did not have any monitoring in place. Calls were rather, our perspective was low number. After several months, it failed. Mistake was, it was a school one from the school books. So each and every API is having its own even size. As every message, every transaction, not only financial one, but every transaction coming from database, going out to it has its own size. Size was building over time. We were not aware, of course, and CPU crashed. And it was misfortune that it was not only CPU, it was memory consumption, and it was physical storage consumption. Cause why it crashed, it was levels of logging. So we said, log everything what you possibly can, and it logged everything what it was possibly to be logged, but building up it at super speed. From the logic point of view, I could say that we did not have any significant omissions. From how we are building things, of course, we had to put some developers some time back on track from the building complexity, and then disentangling their applications to the smaller ones. But it was on the way learning. Mistake as developer, I managed to erase car database in Vojvođanska banka when I started. They had backup, which was real time, which is good. I built some procedure, which was my own internal procedure, but somehow transported this package, which was Oracle Store procedure, to the bank, together with some files. They executed, and that was it. Of course, I never did it before. I was never programming after that. Just kidding. Good. Any more questions?
Thank you.
Thanks a lot.
If there are no more questions, thank you once more.
Thank you. It was a pleasure. Thanks a lot.
Okay, and just, well, many of you there still, but for the record, okay, so the course of software architecture continues, and those who are not directly enrolled with this course and attended this lecture, if you like this lecture, so there will be one more lecture, but it will be by me, unfortunately, on aspect-oriented software modularization. Or aspect-oriented modularization, and that will be our last lecture in software architecture in this course. Then we'll have one more time slot for discussion purposes, and that's roughly it. And I will post the link to the lectures of software architecture to our website, probably. It's Advanced Research Group website, and I can circulate this link, and there will be this lecture as well recorded. I hope it was recorded, because we don't have means to check that. We must I will just wait patiently for the link to the recording to come, and that's it. So hopefully there will be one. There will come one, and then I will post the lecture. Thank you once more for coming. See you next and last time, and maybe then one more time for the discussion if there will be any questions within the course. Okay, that's it. Thank you.